some quick writing of equations, things like that. These are some of the quick little basic skills that we're going to use during first semester. It's just more or less to try to get you guys to remember how to math a few things. What I like to do a lot of times with this stuff is try to relate it to what you're going to see later. Okay, and you'll see a couple examples that as we go through. I know, like I was saying on the board before, I'm so rudely interrupted. It's a joke. Was that I started to think that we'll probably move up the quick graphing because it's kind of going a little bit quicker than I had thought, plus writing equations kind of gets thrown into it, all of it as well. So I'm guessing on Friday we'll probably start some linear inequalities. Again, probably stuff you've done, you just kind of forgot about it, so we'll look into that as well. So one of the things I wanted to talk about today to start with was just plain old boring slopes. And slopes, they never go away. I know they have their ups and downs throughout math, but let that sink in there for a second. He's thinking, he's like, I can only. Sorry, that was bad. It was. We'll get there. Just not 100 hooks up. Anyway, quick reminder. When you have slope, what was the variable that they used to denote slope? What? What was it? M. Oh, X, Y, L, I don't know. M. Okay. Slope, they use the letter M. Now, do you know the reason why they use the letter M? Close, but no. It's a good idea. If you look at slopes, yes, sir. What else did you use M? Well, I'm going to explain to it. Okay. What does an S look like? A 5? All right. What does an L look like? What does an O look like? What is P used for in math? No, it's used for perimeter. It's used for perimeter. It's used for physics. Yes, used for that, but it's also used for probability. We use probability for that. E is an exponential function. You may or may not have done compound continuous stuff in Algebra 1. Probably didn't, but I don't know. S, again, slopes, just plural, another 5. So when you start thinking about the alphabet, about why they got to using the letter M, oops. A, B, and C, what are those used for? Points. Pythagorean theorem, good. What is the letter D used for in math? Diameter, distance. Again, we talked about E, F, G, and H. What are those 3 letters used for? Very good, functions. Use function notation, f of x, g of x, h of x. You see that all the time with those. I, what is I used for? Imaginary numbers, very good. They're the numbers you can think about, but you can't quite talk about. J and K. In math, what are the letters J and K used for? It's not just kidding. There is these things called joint variation and direct variation. Joint variation stands for something like X, Y, and Z vary jointly with something, or K varies directly with M. Things along those lines. It's kind of like a precursor of slopes. Those are what those are used for. Okay, L, again, L looks like a 1. If you had a cursive L, you use it for line. And then they got to the letter M, and they hadn't used it yet. Hence why they used slopes. Kind of. Or that's all just made up, and it sounds really funny because it actually goes for the word modulus. 80-20, man. There's the 20. In math, there's these things called modulus, and that's where the slope comes from. It comes from rate of change. You guys are like, wait, that was all made up.
That's modulating.
Kind of. Again, the idea for slopes, slopes, as you guys were saying, your head like goes, it has its ups and downs, that kind of thing. When you talk about slopes, slopes is a ratio. Slopes is a ratio of what over what? What was it? Rise over run. Yeah, I thought you said it. Your voice is kind of in the same area. Yeah, it's rise over run. Oops. Now, when you're talking about rise, on your standard XY graph, which values are the rise?
Y.
Good. And then by process of elimination, the run is X. So have you seen it written like this?
Yes.
Okay. What does that triangle stand for?
Change in.
Yeah, delta. Delta, change in Y, change in X. Slopes. Guys, slopes are things that you will use pretty regularly. As you get into calculus, you still find the slope of the tangent line. You did this last year in circles. If you did, you had a circle, write the equation of the line that is perpendicular to the circle at X certain point on the circle. We do the same idea in this class, where we'll do it with circles, but we'll also do that with, write the equation of the line that's perpendicular to a hyperbola, things like that. We can do slopes. I can find the slopes of the diagonal asymptote between those two as well. A lot of little things that we'll be able to get to that still relate to slopes. As you get to calculus, you'll start using slopes in terms of what are called derivatives. Slope of the tangent line to a curve, things like that. So, yes, sir.
Well, we have vocabulary in our daily lessons.
What do you mean?
Like when you go over words that we're using in the lesson.
Like multiply?
No, I don't know.
Derivatives, that's something you're not going to worry about until you get to. Actually, you'll do some of those next year. Pretty copy. The bulk of the vocab that we're going to have here is, we're talking like exponential, polynomial, things like that. You'll figure out, oh, that's what that means. Or ellipse, hyperbola. You'll know what it means because you'll know what the formula is. You'll know what it looks like. There's not going to be like perpendicular bisector or acute angles, things like that. Those type of vocabulary really isn't so much within Algebra 2 as much as it is in geometry. Okay? But anytime that there's something that you're not quite sure of, just ask. Because sometimes I have a habit of kind of going a little fast. Talk a little quick and my mind goes all crazy because I like coffee. And goes on. Did you have Canoe?
That's gotta be scary.
No. No, I wouldn't want that. Actually, I don't even need coffee when I'm like this anyway. That's my wife. I'm just. I get out of bed, I'm like, woo. I go work out, I get done. Woo. I take a nap, I wake up. I'm just always. Yeah, a mile a minute. All right, so when you're talking about change by or change in X, when you're trying to work with slopes, you need how many ordered pairs to find slope? 2. Correct. Now remember, when we did this, there was a generic formula that you guys had used before. Okay, change in Y over change in X, and then you're just looking at your sets of ordered pairs. When you're dealing with ordered pairs, what comes first, the X or the Y? X. What comes first in the alphabet, X or Y? X. What comes first in the alphabet, sine or cosine? Jeez, Jeff, you're the worst. You don't know your alphabet? Wow, he threw you under the bus real quick there, didn't he? Jeez. All right, the reason why I'm saying that is because eventually, next semester, we're going to get to what's called the unit circle. Okay? And the unit circle is the basis of all trigonometry. Within this basis of all trigonometry, there happens to be pairs. X and Y comes first in the alphabet, sine or cosine? Cosine, because C comes before S, in case you didn't know. I mean, I could be like a second grade or first grade teacher and just put the alphabet around the wall if you want, or like a number line. Does that make you guys feel better? Could you see me trying to teach second graders? Why can't you math? Yeah.
And yet they move on to pre-trig and they're loading.
Domain and range. Which one's which? Do you remember?
Domain are the X values that you put in, and range are the Y values that you
Get out. Very good. Input, output. Again, think of it this way. What comes first in the alphabet? Domain or range?
Yes.
Which is it?
Domain.
Domain. What comes first in the alphabet? X or Y? X. So you've got your X's, X values go with domain, your Y values go with range. It sounds stupid, but it's the easiest way to remember most of these things. Okay? It's the easiest way to remember most of these things. Oops. I'm not worried about functions right now. Slopes, we did this. All right. Find the slope. What's that?
No, Y is on
It's valid, right? Oh, yeah. Sorry about that. So again, as you go through these things, this is not, ladies and gentlemen, come on. There's 32 of you guys in here. We got a lot to do. Okay. When you're dealing with these things, you've got your change in X, or sorry, change in Y over your change in X. If you can't math it in your head, throw it in the calculator using the fraction bar. If you're using the fraction bar, remember what buttons you press to get to the fraction bar. Alpha Y equals, very good. Alpha Y equals gets you to the fraction bar, and you can type it in exactly the way that it's written, because the calculator likes that. You don't have to worry, when you're dealing with the the minuses and the negatives in the calculator, you don't have to worry about the parentheses around the negative to group it, okay? because it's just adding and subtracting. So the calculator will do all that work for you. Also, what's nice is that when you input it as a fraction, it's going to output it as a fraction for you. And it does it as the top-heavy stuff as well. Okay. Huh? Why do you want a decimal?
I don't know.
Would you rather multiply -4/5 by 17/5, or do you want to multiply 0.8 by 17/5? If you didn't have it. Yes, ma'am. I know you can do that one too. I know that we do the alpha y equals a lot because we'll do bigger ones later. It's just another way of doing it. I know there's a lot of shortcut keys. I try to keep it basic because then people are like, wait, what was that one again? So I know that if we keep with the alpha, it is. Okay. Again, not a big thing. Here lies with this. How many types of slopes are there?
2.
3? No, it's 2.
I hear 2, I hear 3, I hear 4. Which is it?
Potato.
In between. What's one type of slope?
A negative slope,
All right, you have negative slope.
and then you have positive.
Okay, that covers some of them.
And then you have vertical.
Those aren't slopes. Those are lines. Those aren't slopes. Those are lines. What is it? There's a 0 slope. Very good. Undefined. Very good. Again, when you're dealing with slopes and you're dealing with the 4 types, obviously you've got negative, positive, 0, and you have undefined. Now, what I want to do is I'm going to switch these two just in the orders because it's just me. And what I like to do is relate this to what do they look like, okay? If you have a positive slope, what direction is it moving? Okay, if you're looking like this, it's going up and right. Okay, when you look at a graph, you read it from left to right, so your slopes are going this way. There lies what happens with negatives. It's the opposite. Okay. Now, what I want to show you guys real quick is in the calculator. I want to show you this little trick here, and it relates to something that we're going to see in a couple of months. Okay. What happens is you have an equation. But give me a quick slope-intercept form equation of something that has a positive slope. Give me an equation of something with a positive slope. 2x plus 3. Very good. All right. Now, if I take that and I throw it in my graphing calculator, I have to go to my y equals button because that's where it is. I hit y equals. And I'm going to type in 2x plus 3. Did you have the 84 itself? Okay. Pretty good with it. No problems. And then hit the button that says graph. Okay. And like you guys had said, it's increasing from left to right. Okay.
How do I center set my graph?
Negative, do a 10 by 10 grid.
Okay.
Go to your window and change it to a negative 10 min. Positive max, your max would be a positive 10 for both x's and y's. Make sure you put it in the right spot, because sometimes if people accidentally do positive one person, that makes it all up. So when you go to this one, you've got your positive slopes. Now, what happens here later on, actually let me ask you this real quick. What is the degree of that equation? What's the degree of that equation? You guys remember doing that? You probably did it in the Algebra 1 class when they started talking about what are called polynomials. All right, let me ask you this. What's the exponent of the x? What is the exponent value? 1. So what's the degree? 1. What's the leading term coefficient? What's the leading term coefficient of this problem? 2. Is it positive or negative? Positive. So my positive first term, I have an exponent here that you don't see that is 1. Is 1 odd or even? I'm sorry, this is twice now. So what happens here is we have a positive first term and an odd exponent. What I'm looking at here are what are called tails. And no, it's not where I got my dog. Thank you. The tails are what's happening at the ends of the graphs. Yeah. Your dog there. What's happening at the tails of this, oh, is this a function? Yes. Yes, it is. This is a function. This is a function that passes inverted lines. Input output. This one works. So on your tails, as you're working your way, as x gets infinitely smaller, as it gets smaller and smaller and smaller, the y value is also getting infinitely smaller. As the x value is getting infinitely bigger, what's happening to the y value? It's getting infinitely bigger. So that what I'm talking about here are called the tails. What's happening when it's really, really small and really, really big? Okay. Now, what I want to do is go back to your y equals real fast, and I'm going to add a second graph with the same coefficient, same y-intercept, but I'm going to change the degree. I'm going to change the degree to the third. So it's going to be 2x cubed plus 3. So remember, we type in 2x caret to the third. And if you remember this from yesterday, I said that whenever you use the caret button, you have to make sure you hit the left arrow, the right arrow, I'm facing you, to drop down out of the superscript. And then you tack on the plus 3. Now, looking at that, the leading term coefficient is still positive, and the exponent is still odd. The tails will be doing the exact same thing. The tails, the very top of the graph, the very bottom of the graph, the tails will always mirror each other, okay? Because the first term is positive and the exponent is odd. Whenever your first term is positive and your exponent is odd, your tails will always be down, up. What do you think is going to change if the first term is negative? It's going to go down, up. I'm sorry, up, down, sorry. I'm facing you. It's up, down. So go to your y equals again, and I'm going to show you guys how to insert. In the y equals, if I hit second insert, you'll notice that the cursor is blinking under the 2 now. Put a negative symbol. And then just hit your down arrow and do the same thing in front of the 2 here. Second, delete, insert, and then hit your graph, and look what happens to the graph. It just flips it. Insert is right here at the delete. Hit second, DEL. It flips it over. First term's negative, exponents are odd. That's what it does. Okay. How things work via the tails are something that we do with polynomials later on. I think we'll get to that right around Thanksgiving-ish. Right before Thanksgiving, somewhere in that neighborhood, we start talking about polynomials. What we'll be able to do is we'll be able to write equations of like upper degree polynomials, knowing what the tails are doing, and then figure out what's happening in the middle. We can graph via tails and zeros. We'll be able to figure out how many changes of direction. That first graph, 2x was what, negative 2x plus 3? The degree was 1. Did that graph ever change direction? No, it was linear. It's in a straight line. That second graph we put in was the x cubed. What's the degree of x cubed? 2x, negative 2x cubed. 3. How many times did it change direction? 3. Look at it again. Down, change, down. Change direction twice. For every degree that we go, you can have up to 1 less change. Math. Anyway, so back to this one. So we have positive. Ladies and gentlemen, it's thunder, it's rain. Don't worry about it. Again, we're falling way behind first hour, and I don't hold you guys, and I'm not going to hold them back. Okay. 0. What kind of lines have 0 slopes? Yes, so you keep answering. Not to say that you don't know. Yes.
Horizontal.
Horizontal, very good. Horizontal lines, I'm glad you didn't say straight. I was going to throw something at you. Horizontal lines have slopes of 0 because what's the second letter in the word horizontal? Oh, see what I did there, huh? Horizontal lines. Now, what is the equation of every single horizontal line? Y equals some number. Every horizontal line has always the same equation. Y equals a number. Okay? Now, by process of elimination, if horizontal has slopes of 0, what has slopes of undefined?
Parallel.
No! But I like how you had it with such conviction. Vertical lines. Vertical lines have undefined slopes because you can't divide by 0. 0 is in the denominator. Here, every one of these is x equals some number. All right? If you did the slopes for these, you'd have slope would be 0 over some number. Here, your slope would be some number over 0. That's what it would look like in terms of finding the slopes. If you have the same y value, slope is 0. If you have the same x value, it's undefined. That's all that means. Okay. Also in line with the slopes and positive, negative, undefined, and zeros, one of the things I also like to throw in with this is, do you remember how to write some varies? How to write some very simple equations. Now, I don't like to get into much about reminding you all the different forms, but I will say that the one form that we're always going to leave our answers in will be slope-intercept. We're dealing with linear stuff. Remember what slope-intercept was? MX plus B, good, right? So, let's see, we go here. So let's take a minute. See if you remember how to do these. I got to do attendance real quick before I forget. Repeat places. There are 3 parts here. Write the equation of a line that has a slope of -3 passes through a point. Write the equation of a line that passes through those 2 points. And then write the equation of a line that passes through a point that's perpendicular to something. I did not tell you guys or remind you guys of what parallels and perpendicular meant. I want to see if you remember. If not, we've got time. It's no big deal. If you forgot completely, I'll just go yell at Mrs. Keller. That's it. We can all go over there. No, we got stuff to do, guys. All right. I got
Oh wait, no, this is
No, it's just not.
white.
Because I can send help, I just don't
You're supposed to write the equation out.
What is it? No, I thought M was down. Oh, M is well, what is D? I can figure out Wait, What do you set the? What do you set?
It's like it, like we would like to for like 5 seconds. That's like, yeah, I like do math.
Yes, you're still like in the top 3.
I still can.
There's somewhere
I don't know.
it doesn't matter at this point in time. We need to wait a few months.
I don't know if it's a one.
Freshman?
Because it's like
No, that was my point. I was trying to finish up because, hey, do me a favor, don't move your seats. I just put you got that way. Z and trying to remember your guys' names. It's gonna take a little bit. Real quick, as we go through these, see how we did. When you have a point and a slope, you're gonna use point slope.
I don't know what that means.
So you'll remember when you see it. You go, oh, that's a stupid thing. So when you have point to slope, obviously you've got a slope, and here's your 2 points. Throw them in, you got y minus 2 is your slope times x minus 5. Do some math here, you get y minus 2 is negative 3x plus 15. Add 2, you get plus 17. You get that. Alright? Now, here's the thing. When you're writing equations of lines, you now have an equation. You also have a button on your calculator that says y equals. So if you hit y equals, throw that equation in, what ordered pairs should you see in your table? Maybe 5 and 2? Oh, just maybe. Okay, that's a nice way to check yourself. When you're writing equations of lines and you have 2 points, what's the first thing you have to figure out? The slope. Very good. Now on this one, you may or may not have figured it out real quick. 4 and 8, 1 and 2, what's the relationship? Well, okay, so how do you write that in terms of y's and x's? So 1/2 of x equals y? So if you didn't think of it that way, 2 minus 8 over 1 minus 4. Yes, slope of 2. Okay. Now you've got 2 ordered pairs to choose from to drop back into slope-intercept form. Does it matter? I'm sorry, point-slope form. Does it matter which of the 2 you use? No, you should get it right no matter what. What I would suggest, though, is that if this happened to be a problem that had one set of ordered pairs that were positive, one set of ordered pairs that had some negatives in there, use the positive ones. I've seen students not know how to work with negatives. Brain parts, I guess. So if you do y minus 2 is 2 times x minus 1, you get 2x minus 2, add 2 over there, you get y equals 2x. Sometimes when the ordered pairs are set up like that, you might find out the relationship just by looking at it. So I just double the x, I get the y. If not, no big deal. It takes a minute to go through. Now lastly, we wrote the equation of a line that passed through a point that was perpendicular. I didn't remind you guys of this, so real fast. Parallel lines, what's the relationship with parallel lines and their slopes? They're the same slopes. Good. Parallel lines, slopes are the same. Perpendicular lines, Good. Opposite reciprocal. Now remember, opposite reciprocal just means change the sign, flip the fraction. Okay. One of the little tricks that we'll deal. I'll come back to this later. We don't have time for that now. Let's see. Here, whenever I'm writing equations here, I like to. I know that a lot of the stuff is pretty quick and painless, but I also know that students tend to make some pretty dumb mistakes because you guys tend to go too fast. You've got. So first thing I'm going to do is identify what's the original slope of the equation they're giving us. 3. So my original slope is 3. Is this a parallel or a perpendicular problem? Why is it perpendicular? Because it says it, exactly. What's the perpendicular slope to 3?
Negative 1/3 x.
Negative, not 1/3 x, it's just negative 1/3. Okay? And then I'm going to use point slope form again. Okay, I've got my slope and I've got my point. So I start using y minus a negative 6, so it's plus 6, is negative 1/3, excuse me, x minus 1. So let's see, y minus 6 is negative 1/3 x plus 1/3. Okay. Now I have to move that. Oh, it's plus 6. Sorry. Thank you. I was thinking ahead of myself. I have to move that 6 over, but I have to subtract it, correct? Which means I need to do it in terms of thirds. What's 6 times 3?
18.
18. So if I subtract 18 thirds over, aren't I subtracting 6?
Yes.
So what's 1 minus 18? Bless you. There you go. I will utilize fractions all the time. Okay? Obviously, if this was something I was going to have you graph, I tend to try to make sure whenever we graph something, worst case scenario, your graphs will be intercepts that are halvesies. I mean, you could fudge this enough, but it's not the end of the world. I would probably have graphed this in a different method as opposed to slope intercept form. And that's where we come into play when we start worrying about this stuff later on, either tomorrow or probably more than likely Thursday. We do some quick graphing. Graphing via zeros. It's a lot quicker and easier to work with when you use standard. You guys remember what the standard form was?
It sounds familiar.
It was the AX plus BY equals C. And you can do intercept form out of that one. That's a really helpful way of graphing. We actually use it quite a bit for one section that we do in chapter 3 called pure pretty. I've got a couple problems of this, and I'm going to leave it here. I don't want to get too involved. I want to see how much you remember. The ones that I was given to first hour, I have to have papers at all times, so I'm getting back in the habit of putting things where they belong. This was geometry. Points and slopes and things so on. So in here we've got, we should be able to do the first page. These are all sticking at 1, 2.
I'm guessing you should call them soon. Because what we do is have a